This is a presentation on OPNAV Instruction 5119, Chapter Bravo 4, Hearing Conservation. To begin this, I want to talk about the four parameters that make up sound. If we understand these four parameters, it'll make it easier to understand things like significant threshold shifts or how to read an audiogram to see if one has occurred. So the four parameters that make up a sound are going to be frequency, the intensity, duration, and the spectrum. When we're talking about the frequency, we're talking about the perceived pitch, whether or not the pitch of a sound is very low versus very, very high, and we measure it in a unit called hertz, and it's abbreviated Hz. When we refer to the intensity, we're talking about the perceived loudness or the volume of a sound, and we're going to measure this in decibels with a lowercase d and an uppercase b. Well, duration, that has to do with time, so we can use different units of time depending on what type of study we're doing, whether we're doing an audiogram or industrial hygiene survey to assess for noise hazards, and we can measure in milliseconds, seconds, minutes, or hours. And then the spectrum is referring to the quality of a sound, and it's going to take the other three parameters into consideration. So frequency, intensity, duration, and spectrum. Frequency intensity we're going to have to understand in order to read an audiogram. So now that we've talked about sound, let's talk about noise. We're going to define noise as any unwanted sound. And we've got to understand that noise can be hazardous. And being in the military, we're probably going to be exposed to some hazardous noise areas. So hazardous noise is going to be any area, hazardous noise area will be any area that has greater than 84 decibels in a time-weighted average. So decibels, we already understand that as loudness, as volume. 84 decibels in a time-weighted average. So this A here means something, and this TWA means something here. This A stands for A-weighted, and what A-weighted means is that whatever you're using to measure to get these decibels is calibrated so that it is the same sensitivity as a human ear. It measures in the same sensitivity as a human ear because human ear does not pick every single frequency. Think about a dog whistle. A dog whistle has a super high frequency that humans can't hear. So there's no point in measuring sounds at frequencies that we really don't perceive. Not only that, the decibels aren't set at absolutely zero. The 0 decibel on an A-weighted scale isn't zero sound. It's just usually what the normal human being can no longer perceive. Your TWA, that stands for your time-weighted average. Typically, it's an 8-hour time-weighted average. And what this is saying, like say we had a reading of 85 decibels TWA, it's saying the average decibel, right, the average loudness in that area over 8 hours is 85. Well, that would be deemed as a hazardous noise area because it's above that 84. Well, we've also got to consider peak decibel ranges, okay? So whenever we have a decibel range that reaches 140, right? So we have 140 peak, or sometimes called impact noise decibels, that is also hazardous. Because if you think about a range, if you're on a range for 8 hours, there's not always weapons fire going on. So if you took the average decibels, the average loudness of that range over 8 hours, it might not equal 84 decibels. But when live fire is occurring, the sound of those rounds going off reaches 140. So we get 140 impact noise, our peak pressure, and that is hazardous, and that will require, hearing protection considerations that we'll get into in a little bit here. When hazardous noise areas are identified or equipment is identified as causing a hazardous noise, so any of those areas that go above that 84 time-weighted average or that meet that 140 peak decibel sound, we've got to appropriately label these areas, and we're going to label them utilizing the NAVMED 6260/2, which is our hazardous noise warning decal, the 8x10 inch, and then also the NAVMED 6262 alpha, which is our label, our 2x2 inch. If you're familiar with your SSIC codes, you'll notice that this is a NAVMED form, so it is a 6000, and if you know a couple of your secondary numbers, this 2 designates it as preventative medicine. So think about what we're doing with these warning decals. We're trying to warn people, hey, put on your ear protection before you get in this area so you don't sustain any kind of hearing loss. So this is preventative medicine, 6260/2 for your noise warning decal areas. So your noise warning decal is normally posted outside of a door or a hatch that leads into a noise hazardous area. Topside, however, on the ship or weather surfaces are not to be posted. I mean, you can't have these signs on the outside of a ship, obviously. So what we're going to do in those instances, you post it on the inside of the door or the hatch. And then our label, our 6260 slant 2 alpha, that's used to label smaller individual pieces of equipment. Moving on to personal hearing protective devices. Personnel working in or entering designated hazardous noise areas or utilizing noise hazardous tools or equipment shall have hearing protective devices at all times. Double protection, both the insertion and circumaural, the earmuffs are required when working in areas that exceed 104 decibels A-weighted and when working in areas with 165 decibel impact or peak levels. So a quick review of what we've gone over so far. What noise levels are considered hazardous? What two noise levels did we talk about that we're going to consider hazardous? Anytime we get greater than 84 decibels at a time-weighted average or peak levels of 140 decibels and above. What is utilized to label noise hazardous areas and equipment? What is utilized to label noise hazardous areas and equipment? Well, we use a NavMed 6260 slant 2, right, for our areas, and our NavMed 6260 slant 2 alpha for labeling individual equipment. Moving on to hearing tests and medical evaluation. Personnel who routinely work in hazardous areas will be entered into the hearing conservation program. All personnel should receive a baseline audiogram, that's the DD2215, upon entry. You'll get that one done at MEPS. Personnel in the hearing conservation program will receive an annual hearing test, that DD2216. These results will be entered into what's called the Defense Occupational and Environmental Readiness System Hearing Conservation. So this DOERHSHC, that stands for the Defense Occupational and Environmental Readiness System Hearing Conservation, right? This central repository will hold all their data in it. And then personnel should receive a hearing test upon termination of service. When you go to exit the military, part of your final physical will be doing that hearing, that audiogram. Moving on to training, all personnel shall receive training relative to the hearing conservation program prior to working in a noise hazardous area and then annually thereafter. Your topics will include elements and the rationale of the hearing conservation program, as well as the effects of noise on hearing, designated noise hazardous areas and equipment, proper use, maintenance of hearing protective devices, necessity for periodic hearing test, mandatory requirements to wear your personal protective equipment and administrative actions that could result from noncompliance, off-duty hearing health hazards, effects of hearing loss and career longevity, promotion, and retention, and communication in a high noise environment. The hearing conservation program will include entries into the Defense Occupational Environmental Readiness System for hearing conservation. This is where we're going to document and input all the annual audiograms that we do. The medical department representative needs to maintain a hearing conservation program roster and update that roster semi-annually. They also need to maintain a tickler file so they can schedule these annual audiograms, these annual audiometric examinations. They also got to make entries into what's called the web-enabled safety system. And what the web-enabled safety system is the Navy Safety Center's online reporting and data retrieval system. And we've got to make entries into this for anybody who has a STS or a significant threshold shift averaging 10 decibels or more at 2,000, 3,000, and 4,000 hertz in one or both ears, and the person's total hearing level is 25 decibels or more above audiometric 0 in the same ear. And don't worry, we'll talk about threshold shifts a little bit more on these next two slides. So significant threshold shift, we've got two definitions. The first one we have is a change in hearing averaging 10 decibels or more at 2,000, 3,000, or 4,000 hertz in each ear. So let's pull up a DD2216. This is the hearing conservation data. This is the document we're going to put all your annual audiograms on. So if you notice, we have a left ear and we have a right ear. These numbers right here are going to represent the hertz. And remember, the hertz refers to frequency, which is the pitch, the lowness to the highness of the sound. So this is a very low pitched sound, and this is a very high pitched sound. The DD2216 compares your reference audiogram, your 2215, to this new information we're about to get. So when you look at somebody, when you go to put the new audiogram in, you're going to get their old numbers. So what these numbers represent, the decibels in which they heard this frequency. So during this person's reference audiogram, at 5 decibels, they heard the pitch 500. They heard 500 hertz at 5 decibels of loudness. So we've got numbers going through here, right? And look right here, we've got a -5. And you'll see these on audiograms sometimes. Because remember, when we're talking about audiograms and we're talking about assessing noise hazards, we're using decibels on an A-weighted scale, meaning human ear sensitivity. So that's not absolute 0. It's adjusted for the sound that the average human ear hears. So all this is saying is that this person right here heard the frequency 4,000 hertz at 5 less decibels than the normal person would hear it at. Okay, so significant threshold shift again, right? As average hearing loss of 10 decibels or more at 2,000 to 3,000, or 2,000, 3,000 to 4,000 hertz. So 2,000 through 4,000 hertz. So when they go to take their next audiogram, say instead of hearing it at 10 decibels of loudness, right, 10 decibels of volume, it took them till 20. So since it took them to 20, down here when we subtract them from each other, it took them 10 more decibels to hear it this time. And then at 3,000, we'll say it took them to 15, right? Well, previously they heard it at 5, so we have another shift at 10. And we'll say at 4,000, they heard it at 5. Well, they were at -5 before, so again, that's a shift of 10. So when we average these, right, we just get the mean. 10 plus 10 plus 10 divided by 3 equals 10. So they have an average, right, an average 10 decibel threshold shift. So we would call that a significant threshold shift because we average. But my question is, would this require an entry into the web-enabled safety system? And the answer to that would be no, because we haven't reached 25. If this were 5 higher right here, if it took them all the way to 25, then yes, because remember, an entry into the web-enabled safety system is a significant threshold shift of 10 decibels or more at these hertz, and a loss up to 25 in the same ear, okay, in addition to. So yes, this is a significant threshold shift, but no, it doesn't require an entry into the web-enabled safety system, because even these values, even though they're worse than, what that initial one, they're not, that bad. You still can hear normal speech at these sounds just fine. We have another definition of a significant threshold shift, okay? So we also consider any change of 15 decibels or higher in any frequency from 1,000 to 4,000 in either ear. That is also considered a significant threshold shift. So we bring back up our DD2216, right? And we'll say, our range again from 1,000 to 4,000 on this, and we'll say at 3,000 it took them all the way up to 20 to hear it this time when compared to the 5 of their reference audiogram. This current one took them to 20. Well, that was a 15. So yes, that is a significant threshold shift. So again, just to recap our two definitions of a significant threshold shift, any change of 15 decibels or higher at any frequency from 1,000 to 4,000 hertz in either ear, and then a change in hearing averaging 10 decibels or more at 2,000, 3,000, and 4,000 hertz in either ear. Here's another quick review. What form is the reference audiogram? What form is the reference audiogram? That is your DD2215. What system are annual hearing tests entered into? What system are your annual hearing tests entered into? That is your Defense Occupational Environmental Readiness System Hearing Conservation. When is a web-enabled safety system entry required? A web-enabled safety system entry required. Well, that's when we have an STS shift, right? Our significant threshold shift averaging 10 decibels or more at 2,000 from 4,000 hertz, and a total hearing level that is 25 decibels or more in the same ear. So you have the average 10 shift, and it takes up to 25 decibels before you can hear that sound. What is considered a significant threshold shift? We had two definitions. What is a significant threshold shift? So we have an STS when we have a change of 15 decibels or higher in any frequency from 1,000 to 4,000 hertz in either ear, or a change in hearing averaging 10 decibels or more at 2,000, 3,000, and 4,000 hertz in either ear. Hearing test. So your audio booth, it needs to be certified annually by an industrial hygienist, an audiologist, or somebody qualified to calibrate it. If no reference audiogram is in the person's record, they cannot work in a noise hazardous area until that reference audiogram is done. Hearing thresholds, and when we go to do that audiogram, if we have a hearing threshold in excess of an average of 25 decibels for the frequencies of 500 to 300 hertz, or 45 decibels in any frequency greater than 400 or 4,000 hertz, they got to be evaluated by an audiologist. So if their reference audiogram looks like this, right, from 500 to 3,000, they have an average of 25. It takes them to 25 decibels before they can hear. Or if anything higher, at 4,000 to 6,000, it takes them up to 45 decibels to hear. They need to see an audiologist. That's some pretty bad hearing. Still on hearing test here. If when doing your annual audiogram, it shows a significant threshold shift, that individual needs to be retested following at least 14 hours of exclusion from noise levels in excess of 80 decibels. They need 14 hours where they are not exposed to any noise above 80 decibels. So the follow-up process when you do have a significant threshold shift. So if you follow up and there is no significant threshold shift on this second audiogram, well, we're going to go ahead and make sure that your protective device is refitted. We're going to make sure that you're trained in its use, so we're going to re-indoctrinate you in the use. And then we're going to repeat the audiogram in 1 year. You just read right back on the hearing conservation program like normal. If there is still a positive significant threshold shift, if you fail it again, well, you're going to be examined so we can rule out what's called conductive hearing loss, right? We're going to get a screening tympanometry, and then you're going to get an otoscope exam. If no anomaly is noted, you may be given a second follow-up that same day. So if your ear is examined and there's nothing wrong with it, they can go ahead and we don't have to do an additional 14 hours of rest. We can go ahead and do that third audiogram that day. So follow-up number 2, which would be the third audiogram. Well, if there's no significant threshold shift at that time, we just jump back up here, right? Make sure that your hearing devices fit, re-indoctrinate you into the use, and then repeat the audiogram in 1 year. If there still is a positive significant threshold shift, then they're going to refer you to an audiologist, and then depending on what they find there, you know, will depend on what they do, but more than likely your baseline will have to be reestablished. Okay, you still have your reference audiogram, that initial one, but from your subsequent audiograms will now be compared to this new baseline. Now we're going to talk about who's responsible for what components of the hearing conservation program. So when we're talking responsibilities, we got to consider the responsibilities of the commanding officer, the safety officer, the industrial hygiene officer, your division officer, medical department representative, and then of course all hands. Your commanding officer, well, they're responsible to ensure that the hearing conservation program is established and maintained within the command. The safety officer is responsible for requesting assistance from industrial hygienists to conduct noise measurement and exposure analysis so they can do noise surveys. He needs to maintain a record of noise hazardous equipment. He needs to ensure that noise hazardous spaces and equipment are posted and labeled, right? He's got to make sure that NAVMED 6260/2A is on the equipment and that NAVMED 6260/2 is on all the doors leading into a noise hazardous area. He's got to ensure that all permanent significant threshold shifts are reported by the medical department. Your industrial hygiene officer, he's got to maintain and ensure proper calibration of all the sound measuring equipment. He's got to annually certify any audiometric testing booths installed aboard Navy ships. Annually, these booths need to be certified. Your division officer, they need to ensure personnel exposed to hazardous noises have and properly use hearing protective devices. They've got to ensure that noise hazards are properly labeled. They've got to ensure personnel required to wear hearing protection are trained in the use and maintenance of that equipment. They've got to ensure that personnel report for scheduled audiometric testing and training. They've got to ensure personnel who require hearing retest due to a significant threshold shift are excluded from hazardous noise areas, right, for at least 14 hours. Your medical department representative, well, they've got a lot of responsibilities. They've got to coordinate with the division officer to identify and maintain a current roster of personnel exposed to hazardous noise. They've got to conduct training for all hands during indoctrination, and that includes elements of the hearing conservation program. They got to ensure annual refresher training for hearing conservation program enrolled personnel is performed. They've got to consult with industrial hygiene surveys or occupational health to determine the type of required hearing protective devices that are required. They have to schedule annual audiometric testing for personnel enrolled in the hearing conservation program. They've got to ensure the results are entered into the health record and uploaded into the Defense Occupational Environmental Readiness System for hearing conservation. They got to ensure that personnel who require retest due to significant threshold shifts are excluded from hazardous noise for at least 14 hours before the retest. They got to ensure certification of audio electroacoustic calibration of audiometers and audiometric test chambers. They've got to report to the safety officer all permanent significant threshold shifts that have been determined to be consistent with occupational exposure. So all significant threshold shifts that occurred on the job, they got to report to the safety officer. And they've got to enter into the web-enabled safety system any work-related STS like we covered in the previous slides. And then all hands have to comply with the hazardous noise warning labels. And they have to properly wear assigned hearing protective devices and undergo hearing testing when designated. All right, final review. If a service member has a significant threshold shift on their annual audiogram, at a minimum, how long should they be excluded from noise hazardous areas before retesting? How long do they need to be excluded from noise hazards before retesting? At least 14 hours. At least 14 hours. What is utilized to label noise hazardous areas and equipment? What is utilized to label noise hazardous areas and equipment? That's your NAVMED 6260/2 and your NAVMED 6260/2 alpha /2 for the spaces, 2 alpha for the equipment. What noise levels are considered hazardous? What noise levels are considered hazardous? Well, greater than 84 decibels at a time-weighted average, and then our peak levels of a 140 and above. So greater than 84, and then peak levels of 140. How often do audiometric chambers need to be recalibrated? How often does your audiogram booth need to be recalibrated? Annually. What form is the reference audiogram? What form is the reference audiogram? That's your DD2215. DD2215. What system are annual hearing tests entered into? What system are your annual hearing tests entered into? That is your Defense Occupational and Environmental Readiness System for hearing conservation. When is a web-enabled safety system entry required? When is a web-enabled safety system entry required? That is when we have a significant threshold shift averaging 10 decibels or more at 2,000 to 4,000 hertz, and total hearing level is 25 decibels or more in the same ear. So an average significant threshold shift of 10 decibels, 2,000 to 4,000 hertz, and it takes up to 25 decibels for them to hear that sound. What is considered a significant threshold shift? What is considered a significant threshold shift? Remember, we got two definitions, right? A change of 15 decibels or higher at any testing frequency from 1000 to 4000 hertz in either ear, or a change in hearing averaging 10 decibels or more at 2000, 3000, 4000. All right, 15 decibels or higher at any frequency, 1000 to 4000. Average of 10 decibels, 2000 through 4000. All right, that concludes its presentation. This is all from your OPNAV instruction 5100, 19 Alpha, Navy and Occupational Health Program for Forces Afloat. Keep studying.